One thing the oil and gas industry produces a lot of, other than oil and gas of course, is brine. Salty water that is co-produced during oil and gas extraction. Right now, all that brine needs to be sent back underground for safe disposal after the oil and gas has been stripped out. But what if this waste stream from today's energy industry could become a new energy resource unto itself? What if the future of critical minerals was hidden in something as simple as oilfield brine? In Alberta, E3 Lithium is leveraging the province's abundant oil and gas expertise to pursue breakthrough innovations in the emerging domestic lithium industry. Their solution repurposes legacy oilfield aquifers to extract lithium using a low-energy and highly selective extraction process. Simply put, they are turning what was once a waste into a key ingredient for new technologies like batteries and energy storage. This initiative positions Alberta as a leader in the global critical mineral supply chain while driving the electrification revolution with locally sourced lithium. With a referral from Alberta Innovates, E3 Lithium secured $5 million in funding through ERA's Continuous Intake Program. This funding will go towards upgrading their first extraction facility located in Olds, Alberta, where they will conduct small-scale tests to reduce innovation risks and gather critical data. This data will in turn pave the way for a full-scale commercial facility set to start construction in 2026 and will help determine just how much lithium can be produced annually. We wanted to learn more, so we sat down with Chris Doornbos, President and CEO of E3 Lithium, to explore their mission, the breakthrough behind their selective extraction process, and the role of strategic funding in de-risking this transformative project. Here on Carbon Copy. We're really happy to have you with us this morning, Chris. I think where I'd like us to start is just by you giving us an overview of E3 Lithium. What's your mission? How does it fit into the broader state of the national and global critical mineral supply chain? And what are we looking at in terms of the ERA project?
Yeah, so E3, like the goal that we set ourselves out with back when we founded the company in 2016 was to develop a nascent industry in Alberta. We weren't the first necessarily to think of this idea, but we came at it with a bit of a different approach. Really what the company is doing is repurposing a historic aquifer that was discovered in the 40s for oil that still produces a little bit today, but most of the oil economic oil has been produced out of this aquifer. And so the majority of what it's filled with is lithium enriched brine and has been since the beginning of this aquifer. And when you look at it from that perspective, we have a deep understanding of how to produce fluids from this. And our goal has always been to find a way to get the lithium out economically. And we recognized early on that the secret to that was going to be an extraction technology that enabled you to selectively get the lithium out of this very salty water, because the percentage of lithium relative to all the other salts is very, very small. But when even the small amount of lithium in this water, the value of any other metal that's in there that you could potentially take out, like calcium or sodium or magnesium, is eclipsed by the value of lithium. And that is because of its use now in the battery world as the main conduit to transfer electrons. And so through a lot of work over the past 8 years, we've developed technology to extract the lithium from the brines. And I think the original goal was to become a resource development company. So we're going to produce a product. It became very apparent, in fact, pretty early on in the company's history, that we will end up providing to make this company viable. We had to make a product that we could sell directly to a battery company. And so we spent a bunch of time working through that challenge. And so our customers that we will sell our products to are going to be, in most lithium is still sold this way, directly to the end use customer. And the end use customer is in the battery or the automobile space. And that's quite a bit different than how most companies in Alberta and even most mineral development companies operate. Most of the time, they just make the raw product, the concentrated. If you're hard rock, it's in lithium, you call it a spodumene concentrate. And if if you're in the oil and gas industry, it's crude oil. And then you sell it to somebody and they refine it and make the product that can be sold to the consumer. And we will do that refining here in Alberta. And it enables us to capture much more value for the product. It's not that much more expensive to go that extra step for us because of the technology that we've developed. So it gives us this really interesting sort of paradigm where we're a mineral resource company, but we're playing in this space of the automobile industry in the critical minerals sector. And so we've been pulled into a whole pile of conversations that you wouldn't normally get involved in because of this critical mineral side of things, because of the national security side of critical minerals. So we spend a lot of time with government. We spend a lot of time with multinational major corporations that could potentially be our customers one day. And so we've had to develop those relationships and sort of that way of operating as we've built this company. So now the mission really is to develop a nascent industry in Alberta, but to bring the industry to Alberta, because we have what a lot of other jurisdictions for lithium don't have, which is infrastructure and people. Mostly where lithium is produced, the raw materials produced, is in very remote locations. And we are not remote. We are in the central part of Alberta. We operate like conventional oil and gas in an area that is all conventional oil and gas. That is the main economy driver. And so we have a really good opportunity to do more than just be a raw material producer. And, we can talk more about our partnership with Pure Lithium and how we sort of see the industry, the battery industry evolving in time. Because right now it's still very new. It's only 10 years old, really. Right. So this still, as an industry, very, very mature. But that's our goal, is to develop, obviously first goal, develop a lithium product that we can sell directly to battery companies, but then also bring the industry here.
Fantastic. And I love that evolution that you spoke to of, starting out, our mission is to produce lithium, to now your mission has matured and you have that, okay, our mission is to be a sort of full service, partly vertically integrated provider of this material into the battery producers, and the level of integration, the level of strategic thought that goes into that is really, really interesting. So you spoke to the fact that ultimately what we're talking about here is going into reservoirs, extracting brine, and producing a lithium product from that. Can you maybe take us in a little bit more detail into the specifics of that lithium extraction process, and just maybe contrast for our listeners how that compares to what you alluded to earlier, which is there are some similarities with oil and gas production, especially conventional oil and gas production, but there's also some key differences. So if you can just maybe take us through a little bit of a compare and contrast there, I think that would be really illustrative.
So the technology that we are developing operates like a water softener, is the best analogy. And we use this type of technology all over the world in many, many applications to treat water. What you're doing when you're treating water is you're removing, with ion exchange or absorption processes, is that you're extracting things out of the water to clean it up. So in a water softener, you're taking calcium out of the water and you're replacing it with sodium. And what that does is it softens the water. What that does is it softens the water. It takes the calcium out, which makes it hard and produces scaling in your pipes and whatever. The process that we use to get lithium out is exactly the same. Obviously, we're trying to get that out of the water for value, not trying to clean the water necessarily. The selectivity of the material, our ability to just extract lithium from the water, is a pretty fundamental part of what this technology needs to do. Because the more efficient it is at extracting lithium out, the more you get out, the higher the recovery, and the less of other things that come with it, enables you to purify it into because battery grade, if you quote unquote battery grade lithium, is pretty much 100% lithium, is pretty pure. And so you're sort of achieving two goals. and how this works is pretty straightforward. It's low energy, which is what we really like about it because it helps reduce cost. So you manufacture what looks like a little bead. It's a solid chemical, and you flow the lithium-enriched brine through this in a tank. And the lithium molecules stick to this material, and they bring a chloride with them because all of these brines are basically a sodium chloride or a salt brine. So it brings a chloride with it. And so then you have a lithium chloride stuck to this material. And then eventually you sort of fill it up, right? You've got all of the sites that are available to select lithium filled. And this is all done experimentally. And this is one of the big reasons that you go scale this to the next level, which we're going to do with the demonstration, which is part of what the area is funding, is to do it at a larger scale to optimize. And that's the fundamental part of making sure that this operates efficiently, is the optimization of how full this material can be until you switch it off. Then you do a quick rinse, and then you strip it off with pure water. And that stripping of the lithium chloride creates a lithium chloride in water. So you basically make a bit of a lithium salt in water. And then from there, and the project that we're working on right now to get that operating, which we hope to have running here in mid 2025, is basically a full representation of that system at full operating commercial parameters. Now, smaller scale, so the flow rate is going to be smaller, but it will mimic how a commercial plant operates. And I think that step is pretty important for companies like us because it helps de-risk the project. And when it comes to the thing that we're going to have to do, that's going to be one of the big mountains that E3 has to climb, is the financing of the project. And so doing a demonstration significantly de-risks the project. And that is really important for those banks that might be lending you the project financing.
Absolutely. I think that's such an interesting story, and you've outlined it really, really well, which is, I think when people hear brine or salty water, they just picture sort of, maybe ocean water, or they've mixed some table salt in and that's salty. But when we say salty water in the context of this, we really mean there's a whole bunch of different salts in that water, and what we need to do is get it down to the point when it's just the salt we want, just the lithium salt, and then, like you say, further process that lithium. That word you mentioned, selectivity, is so important because we really do need to be able to select for the salt we want, for the lithium molecules in that broader mix of salts that are in the water. And I think that's one thing that we're really excited about with your technology, is the ability to achieve sufficiently high selectivity for the technology to be viable with the types of and concentrations of brines that we have here in Alberta. So that's really, really exciting. You touched on your pilot project that you launched with Alberta Innovate support. Can you maybe just take us through a little bit more about the scale of that pilot, what you were testing in those operations, and what the outcomes and learnings were?
Yeah, the pilot that we ran was... it was if I could use the phrase TSN turning point, it was a big transition for E3. Because when you look at the processes that we're going to deploy, and you asked this question earlier, and maybe this is a good place to answer it, about how we're similar to oil and gas. When you look at the technologies we're going to deploy, up until you get to the direct extraction process, this is oil and gas Alberta we do every day. So it's drilling a well, it's moving a fluid from that reservoir to a central facility. In Alberta, you might call it a battery. And then you separate the fluids, gas and liquids. And in oil and gas, you're separating gas and water, or oil and water, or oil, gas, and water. And it depends, we would say 2 or 3 phase separator to do the separation. And it's really just quite simple mechanics of oil floats on water, or gas can dissolve out of water. And so in an oil and gas scenario, that water is your waste product, often called wastewater in the province. And then you put that back into the aquifer. You don't want it anymore. And then you take the oil and the gas out and you sell it to market. In our scenario, we do have entrained gas, so we'll have a 2-phase separator, and we'll be separating the gas out. We don't want the gas. There's not a lot of economic value in it, actually, so because it's very low methane. So we will most likely dispose of that and keep the water. And then we run the water through the direct extraction. That's the technology that's somewhat new. And then once it comes out of direct extraction, it goes through water treatment processes, reverse osmosis, filtration, ion exchange, all of these things we use in the water treatment world. And then it goes into carbonation to make the carbonate. And then if you're going to make hydroxide, you take the carbonate, convert to hydroxide. That's a stock standard lithium processing plant that are in North America. So what we went out to do with this pilot in 2023 was to test the sort of key to this project, which is the direct extraction processing, and do it at a scale that was meaningful, operating it in a way that as close as we can at that size mimics a commercial plant, so you can optimize it and you can understand it. And so when you look at the goals for this, one was simply, can it work at the flow rates that we've never been able to achieve before, because it's hard to move that much water in a lab environment. And then while moving larger volumes, can you still get the recovery of lithium? Because you move the same volume of water, recovery becomes fundamental to the success and to the value, because you have to move that water regardless. But if you get more lithium out, you make more money. So you want higher recoveries. So you're testing that at the flow rates that you want to mimic for commercial, and you're testing all of the other performance. Those are the big check boxes from the pilot. The smaller check boxes are really more about process optimization. Can you make it really efficient? And these are things that's really hard to explain in a simple like news release, for example, where you're trying to explain what you're actually testing. And so we put out a couple of KPIs that are the big check boxes. One of them was a flow rate ratio. And that was really how much lithium you can get out versus the flow rate. And that is so fundamental to success, because you want to move this water pretty quickly. You don't want to handle it for very long. The total residence time is in the hours from when the lithium molecule, or let's say the water, leaves the aquifer and is back into the aquifer after it goes through the process. It doesn't take long, and you want that. You don't want to handle this for very long. So you want to move it pretty quickly through the system. And so what we ended up with at the end of the day was we tested more than one technology. And the reason for that is that all of we tested ours. So E3 has developed our own technology. And then we also, and what that means is that we've developed our own ion exchange resin or sorbent, the chemical material. And we also tested third-party companies' processes and that sorbent, that lithium extraction chemical. And what we ended up deciding to do was to use a third-party sorbent and work with them on the processing, so that the process was developed specifically for E3, but using a third-party sorbent. And the reason for that is just time. They were commercially available, and you could just order them. And we could order enough for a commercial plant. Whereas for us to develop ours, to get it to the point where we could manufacture it with a process with enough material for a commercial facility would take years of development. And we still plan to do that. We are still progressing that manufacturing of the material. But we need to get on with effectively trying to get to making revenue. I mean, the goal of this company and any for-profit company is to make profit. And so spinning our wheels on technology development, considering there were viable options that were economic for us out there in the world, it just made the most sense to make the switch. But the process design that E3 is still deploying for this is something that's being developed in-house with an external engineering firm. So we're still doing a lot of the process optimization. And to that point, we still have a lab that operates. And everything that we do, we test first in the lab. And we've got a great team there. And we've got a very small version of what will look like a commercial DLE system in the lab. And that thing can run and do a lot of the optimization testing ahead of the demonstration that we're going to be deploying here. So, and all of the learnings that we have, I think, have led us to the success and our ability to go and go at this scale from the pilot. I think it's important to note simply that this is new. I mentioned that the lithium industry, the battery, Tesla started putting batteries in cars in the 2000s. They were in computers and cell phones around that time too, and they're literally strapping computer batteries together in the first prototypes. GM was working with lithium ion in around that same time, like 2007, 8, 9. That's really the advent of large scale lithium ion batteries. They're not that old, and in terms of like the rest of the world getting into lithium ion batteries for electrification of transport, for example, really the end of the last decade. 2018, 2019, people really started to talk about building these big gigafactories like Tesla had built with Panasonic in Nevada, and producing these. So this industry is still new from all angles. And so being able to find skill set that knows how to do lithium extraction, it doesn't exist. There are very few people who have a commercial operating DLE plant. The first one outside of China is operating now in Argentina. A company called Aramet is expected to have the full operation running in November, and they've been commissioning over the past couple of months, and that's pretty exciting because that's the first one outside that we, from a publicly traded company, they actually go and see the data from and see it operate from the public view. There is a bunch of projects in China that are operating. It's just harder to see into those operations to understand how economic they are and the process that are running. And so we're starting to bring this into North America in a big way. I think in the next 5 years, you're going to see 4 or 5 DLE projects up and running.
And I think that's such a critical thing to think about is the whole world is in a bit of a gold rush, if you will, or lithium rush. And so there's companies and governments across the world trying to see how they can take advantage of their lithium resources and become a global exporter. So it's really, really exciting to see folks like yourselves, and you alluded to a couple other North American companies that are leading the charge and trying to make sure that we get some of that growing market for us here in North America, and specifically in Alberta. It's really, really great to see. But I think the other point you made that I really like is this is still in this, if you look at the scale of technology adoption, lithium ion technology is still relatively new in the grand scheme of things, and this market is just developing. So I think it's fair to say that we are at the beginning of what could be a very large and frankly exponential growth trajectory for this market. And again, getting in on the ground floor as opposed to trying to compete with folks once things are fully established is definitely where you want to be, and it's the role of innovation. So again, kudos to you and your team for seeing that potential and for getting Alberta and Canada in on that train early. The other piece I took away is, a really fascinating insight into the process of innovation and what it takes to get these technologies over the finish line. I think people often just think, you have to get one technological breakthrough and then everything works. And I think in reality what you spoke to, which is we know how a lot of these technologies work. There's sort of a couple of keystone technologies that we do have to invent or do have to fundamentally improve to get them there, and then the whole system comes together and works. And I think that's really, really valuable to think about innovation in that perspective. We do have to push all the technologies forward, obviously, but there is going to be that central piece that comes forward and makes this happen. And I actually see an allegory of the oil sands in that, right? We know the resource was there, much like lithium, but it's not a conventional resource that the conventional producers, again, oil producers or conventional lithium producers, are used to, and we need a bit of technological innovation to make that industry work here in the Alberta context. And so again, really, really exciting to see that innovation being pushed forward.
It's a good point because, the SAGD is a great analogy where government supported the first technological development, and you got a project up and running. It proved it can happen, and now look at the size of that industry and how much revenue it generates for the province. And so I think it is really important, sort of, if we put the size of what the lithium industry can be into perspective. We have the most lithium resources under National Instrument 43101, which is the code that we report our resources under, in the world, in Alberta. We have a large amount of lithium here. And so the size of the prize is huge for this province. Should companies like us be successful, and we're not the only ones operating in Alberta. There are other companies. We're certainly now leading the charge with the technology development and with the path towards commercial. We're the most advanced, but there are others that are doing very good work to develop a project as well. And so the success of one is the success of all.
you're absolutely right. The industries today that are all successful and bankable and sort of well-known and understood were all risky, unproven innovations 20, 30, 40 years ago. And it does take time to get from that point to where they are today. And I like to think we're at the start of that journey with lithium. Let's talk a little bit about the proposed and recently approved project that Emissions Reduction Alberta will be supporting. We know it's the next phase of that pilot that we talked about that had been previously supported by Alberta Innovates. So can you maybe speak to how ERA's investment is being used to further scale and advance the technology, and what the context of that project is in Olds, Alberta?
Yeah, I think for us, it's very exciting to go to this next scale, because if this is successful and we do this right, it should be the last scale up before we're talking to banks about funding a commercial facility. And it is going to be the full scope. So it's going to go from the brine in the aquifer to a lithium carbonate produced. And so being able to bring all of these operations together, I think is really important to show that, demonstrate on the technical basis that it can be done. There's a bunch of things that you just can't test unless you're out in the field. And those things significantly de-risk the project. One of them is the separation of the gases and making sure that you can get enough of them out in the design that you have. So verifying that design, which we had in the pre-feasibility study, to ensure that we see enough gas coming out. So when it goes through the DLE system, it operates as we expect it to. We are in the process in the lab of commissioning the carbonation circuit. But the carbonation side of things, we're developing that, we've bought all the equipment and we're building that in-house. And the main reason for that is that it's a skill set that we want to develop with our staff so that they can understand it and they can therefore understand how to operate a commercial plant. And at this scale, we didn't want it to be automated. And the reason for that is, again, training. So we had a really good opportunity to go down to Nevada to see a similar demonstration plant operating. So a Canadian company called Lithium Americas Corp is in the final stages of getting their project built. They just received their funding. They're in Nevada. And they are probably the first major North American lithium project that will get off the ground, that will go from a product in the ground, they're a clay resource, to a battery product. One of the big things that we noted in that is one of the things they were pushing is that how important the training and understanding how to operate this thing is going to be, because we don't often talk about the workforce. And while we have very skilled people in Alberta that know how to do the whole front end, including the DLE and really water treatment, we don't really have any skill set in Alberta for doing carbonate conversion specifically. So building that skill set and having people who understand it intimately, understand the challenges, what can go right, what can go wrong, is fundamental to being able to successfully commission a commercial plant. So we wanted to do that in-house. And so that's now operating in the lab. We announced we were commissioning it, and we're going to start producing a lithium carbonate. So we have, from the pilot last year, we have concentrate that we produced that we saved. And so we're going to take that concentrate that was produced, so it's real Alberta lithium molecules that we produced in the pilot, that we're going to convert into lithium carbonate in the lab. That's our goal, at using the demo equipment. Some of this is already at demo scale that we're already operating. We're just, the only thing that's stopping us really from going today is the equipment. The other learning that we got from our friends down at LAC in Nevada at their Thacker project was the importance of being able to show your customer that you can make the product. So when we're talking to potential, multinational companies that have no presence in Alberta today, about coming to Alberta to, buy their lithium, being able to show them the product, being able to give them some to take home with them, at battery grade, that they can do their own analysis on, that they can verify meets the specifications that they require for their batteries, is incredibly important. And that was one of the learnings also that we had. So it sort of does two big things. It allows us to operate this full system from one end to the other, optimize it, understand how to optimize it, so that when we're building the commercial plant, that understanding's already there, and therefore that it's a huge de-risking exercise, which will ultimately lead to a better success in our project financing, which will be the next goal once feasibility is completed. And then the other piece is this is attracting commercial customers, our off-takers, partners to the product by being able to provide them some.
Yeah, it's such an exciting time in a project when things are actually being fabricated and getting onto site. It's real now, it's happening. So really exciting to hear you're at that step. I'd like to pick up on that last point, which is the critical nature of connecting with customers, building up that market acceptance. I think earlier you spoke to, we're not just producing a purely raw product. We are doing what I think what a lot of people agree we should be doing in Alberta, which is we're making that value-added product that we can then sell for that higher return. But you still do need the end customer ultimately. So what does it look like in terms of the process of building those relationships with battery manufacturers, with automobile manufacturers, and how do you leverage your existing relationships to do that?
We set out years ago to start developing those relationships, and we started traveling to where batteries get made. The largest battery manufacturers today are Chinese. So CATL produces the most batteries on the planet. In North America, there's not a big North American based battery company as of yet. And there are some companies trying to do this, and we're partnered with one of them. General Motors just joint ventured to own 38% of a mineral project. And the rationale for that, from what we have seen, is that there's this need to get the product, and there's a need to get local product. And so you end up having to be a bit creative in terms of how you get access to that. And I'm not an expert on the relationship between the two companies, but you have to imagine that for General Motors to invest in that company and joint venture, that they had a fairly strong need for the product. So we've been working really hard to develop relationships with all of these companies that are building cars and building batteries in the Western world, and have been traveling to Korea since 2018. So from the very early days to build relationships. And, we don't have a product to sell today, and we won't for years. But seeing the way the industry is going and the size of the opportunity here in Alberta, so E3 can probably produce somewhere between 100 and 150,000 tons a year, and that's going to have a operating life of somewhere around 50 years. So you can develop long-term relationships because we have the resource here, and we can expand to multiple facilities producing lithium. And what that really means is that we can attract a larger player to our project because we can provide them with a large amount of material, and we can scale that. We can continue to give them more as they need more, and continue to build and expand. And so that's quite attractive. I think also jurisdictionally, Canada's on the top of the list right now for where to go get battery materials from. But we still don't produce them. We have a couple of hard rock mines that make spodumene, which is the precursor material, but none of that is made in Canada. None of the battery products are made in Canada today. So we don't make a lithium carbonate or a hydroxide in Canada. And in fact, North American operations, there's still very few that actually produce battery materials from materials sourced within that same area. So I think the whole of North America from North American sources produce about 4,000 tons of lithium carbonate today, which is far lower than the demand even today. And you're expecting it to ramp up to somewhere between 500,000 and 1 million tons by the end of this decade, and we're making 4,000.
And I totally take your point. The world is looking for more of this resource. In particular, local companies and governments in North America are looking for more of that resource to come from North America. So, why shouldn't Alberta be that supplier of choice? And I think it's just one of those things of if there's any way at all that we can make this happen and take advantage of that market opportunity, I don't know why we would turn away from such an exciting economic prospect.
Well, it's such a huge diversification opportunity. I mean, it's just another commodity, right? That's the sort of fundamentals. But because we operate it like an oil and gas project operates, we have the skill set already here. We don't have to import people, and we don't have to upskill really most of what we need to do.
Yeah, how cool is that? It's we have the talent, we have the local services companies already, we have the fabricators, we have the equipment. So yeah, it's great that those stars all seem to be aligning. So maybe I'll flip the script on that, though. So there's a lot of good reasons why we should be doing this in Alberta and why we have a lot of the right elements for success. What are some of the challenges you faced in trying to scale up this technology and this business opportunity?
I think they all come down to availability of capital. Fundamentally, is your ultimate hurdle. If someone gave me $1 billion to develop a lithium industry in Alberta, we probably already have it running. That's not realistic. So I wouldn't ever expect that to happen. You look at the tech companies, and that's how the big guys deploy capital, right? They flood it with cash so that they can build it faster and then dominate the market. Hard commodities like things like batteries or even the raw materials that go into batteries, that's not how the industry operates. Because of the risk profile, there's developing mineral projects has a higher risk profile than, say, developing an app, just inherently, right? There's way more moving parts. And so you spend a lot of time engineering ahead of the game. So, and it's why when you talk, there are a couple key pieces that mean mineral projects take longer to get off the ground. One of them is that you basically go from zero revenue to all of your revenue, right? There's no ramp up. You build a plant and you have to spend a lot of money, capital, to get to revenue. So you basically go from no money, then you spend a big chunk of cash to build a plant, and then you make billions of dollars, right? And so that risk profile, therefore, is that you want to do all of your engineering to a very high level. You don't skip steps. Like in an app, you might put a beta version. There's no beta of a plant to make lithium. You have to go all the way to the end product. You have to think of all the problems that might occur, and then you have to engineer them out so that you have something that operates successfully, because failure is not an option when you're building a facility of this size. So that's one of the things. The other thing is that you're building something on ground, which means that you need permits. And permitting is one of the big things that especially in the Western world, projects get hung up on. And if you ask somebody outside Alberta in the mining industry, they would tell you that that's the biggest risk. That's the biggest thing that Canada needs to do to fix its industry. And the Canadian federal government has actually talked about streamlining permitting, and Wilkinson has mentioned that several times, that's a big goal of Natural Resources Canada to streamline permitting. In Alberta, we simply don't have that problem. And that is thanks to our previous energy minister, Sonia Savage, who brought Bill 82 to the floor after a bunch of consultation that she started shortly after she came into term in 2019, which E3 was a part of, to get regulatory authority into the hands of the Alberta Energy Regulator, which we did. And they've been rewriting directives to make that fit, and they're still in the process of refining all of those. But we have a home for lithium now, or what we call now in Alberta brine-hosted minerals. The de-risking of a project is the biggest hurdle. The biggest risk you face is financial, because you have to build this big facility and you have to finance that. And the way you mitigate that risk is by doing all the other work, which is the engineering and the demonstration plants and all the things that you need to do to de-risk this project. The other side of this that we face is that it's new tech. Like I said, there's only one really Western world DLE facility, and it's just getting operating right now. So there has been a lot of doubt from the pundits in the lithium space that DLE is going to be a technology that's going to be deployable. And so I think that when you look at what the disruption that DLE can have as a whole in the lithium industry, it's huge. And we've, if you're out there permitting a hard rock lithium mine right now and you're trying to get it going, you're going to be successful because we need all the lithium we can get at the moment. But because of how efficient the systems are to do direct extraction, in my mind, they will dominate the landscape for lithium production, especially in areas where you're conscious about the environment and you're conscious about sustainability and all of the other aspects. ESG discussions guide in places where ESG guides your decision making, like you have a permitting regime like you do in Canada. The impact for developing a DLE project just inherently is just a little bit less.
And I think that's really one of the reasons why ERA is interested in investing at this time in DLE technologies, in lithium production technologies. We know that all technology, whether it's legacy assets, whether it's for the clean technologies, new technologies, are going to require some form of mining, some form of minerals. But of course, we want those impacts of that mining to be as minimal as possible. And I think you're spot on. When you look at DLE, you compare it to pretty much any hard rock process. There are some pretty significant environmental and maybe even economic benefits to doing it the way you guys are proposing to. So one of the reasons why we're so excited to be supporting this initiative. And of course, how cool would it be if Alberta Lithium #1 is just down the road from Alberta Oil #1? They're going to have to expand that museum maybe. I think we've been talking very much in a broad scale, as we should be, about the longer term potential and all the steps that you're going to have to accomplish to get there. And so you said it's sort of a mountain, and we know it's not going to be an easy journey. But maybe let's just dial in a bit and sort of if you can forecast me out 12 months from now, what do you expect E3 to be doing? What do you expect? What sort of the measure of success if we reconvene 12 months from now and we look back?
Yeah, I think we got a couple of goals for 2025. One is obviously the demonstration, getting that up and running, and that's well underway, as I mentioned. And obviously, the support from ERA has been hugely impactful to that. The other big lift is the feasibility study. So we're done pre-fees. We move on to more detailed engineering. That will get reported out as a feasibility study. Really, what you do when you engineer a plant is you're continually increasing your level of engineering. As you go, you get to a certain point where you have enough information to report it under certain standard. And so, in 2025, we expect to be able to report the level of engineering out as a feasibility study as we march towards a fully designed plant. And the other big piece is obviously commercial. Having the pre-fees out means that we can have open conversations with potential partners because we have a very rigorous level of understanding of what the project's going to take to get built. And that understanding obviously increases as you continue to engineer, but it really does open the door for those conversations to happen in earnest. And so that's another big push for us for this coming year. Is to really engage on that commercial front. It's going to be a big year for us. Every year I say that. Every year the year gets bigger. 2023 was all about piloting. 2024 was all about engineering and getting that out. 2025 is going to be demonstration and the feasibility, and really moving this project forward. You can never predict exactly when, but I would imagine sometime around the end of 2025, plus minus. A lot of those pieces should be coming together. And you look at a proxy like I was mentioning with Lithium Americas Corp. I mean, they first announced their agreement with GM almost a year ago, and now a year later that original agreement converted now into a joint venture with GM. They've got their loan facility finalized from the Department of Energy, and now they're going. There's nothing stopping them other than time to get their project up and running. They have all the pieces they need. And that's a similar proxy. I can't say we're going to do it exactly the way they've done it, but the general steps. And those steps really are going to happen in this next 12 months. So it's a pretty exciting for the company, because we'll be validating this thing as a real true commercial opportunity. And hopefully all of those pieces come together that we can say, at the end of 2025 that we're getting ready to really start the next phase and the next phase is the final engineering and getting into procurement, getting all of the various pieces, because effectively what you're doing is you have all of these different initiatives that are all running in parallel: engineering, demonstration, strategic partner conversations, permitting conversations, stakeholder engagement conversations, government conversations, across the board for funding or for just relationship building or permitting. All of those things, you're sort of pushing the whole initiative forward in one multi sort of front. And they all start. You start to check the boxes, right? You start getting your permits in, you start getting your funding, you start getting your engineering done, you get your demonstration done. All of these things start to happen, and when you get them all done, you're ready to start building. And I think that just like that is pretty exciting for a company to be at that stage. And it's taken us a long time to get here. I mean, I founded this company in 2016. But now it's like the snowball is pretty big and it's rolling pretty heavily down the hill now, right? So, we're not so much trying to lift this thing up. We're more just trying to keep up to it as it moves forward.
Fantastic. So I think it's safe to say it's going to be a very busy year for you folks, and we're really excited to see what happens over the next 12 months over the course of the ERA funded project, and of course over the longer term, as you said, we're continuing to build towards this huge market opportunity.
Yeah, I think the thing that I would really emphasize as we close out is that while this industry is still new, there's lots of opportunities and gaps forming, and being in this, it's an exciting space because you're really building something that is, in 10, 15 years, we're going to look back on and say, well, we had no idea what this was going to become. And a good example is battery technology. And I think the battery tech is going to continually get better. I think the lithium batteries are going to get safer. They're going to become more ubiquitous. And as those things happen, you're going to see more and more applications for the batteries as people can buy them by the truckload and put them into devices at various different formats and sizes. And one of the things that E3 has been working on is trying to find a partner to climb the vertical in the battery space. And we've partnered now with Pure Lithium, and we're working through a joint development agreement that will hopefully lead to a JV in the future to bring battery manufacturing to Alberta. Because again, very rare is it that you have infrastructure where the source of lithium is, and we have that in Alberta. So we have the opportunity to not just produce the raw materials, but also bring battery manufacturing, and that is my goal. I want to see batteries made in Alberta. And again, you walk before you run, so we'll make lithium products first, right? But I think that in the long term, that is a very viable opportunity for this province. And when you start talking about making batteries, you start talking about lots of people being employed in these quote unquote gigafactories, and you're building a highly skilled workforce in the battery industry that can be deployed anywhere, because this is becoming ubiquitous in terms of batteries are being built all over the world. So I'm really excited about that. I think Alberta has a big part to play in this electrification world, and I really like this does not subvert our current major economy in the province. It just diversifies our skill sets and produces revenue for the province, and allows us to participate in another industry in a fulsome way. And I think the opportunity for lithium is here in the province. So we're very excited. I wouldn't want to be anywhere else.